Hi, everybody. Can you hear me all right? Yeah. My name is Einar. I come from Norway, so I apologize for the accent. I work for NRK, which is the national public broadcaster in Norway, so sort of like BBC, but for Norway. Basically, anytime that someone in Norway wants to watch TV or listen to radio for that matter, over the internet, then they sort of interact with the systems that I work on with a lot of other people. So the topic for today is sort of an, I suppose, a philosophical investigation into what this technical debt thing is. Everyone uses this term, but I'm sort of like to dig into it a little bit. For sort of like a backdrop for that discussion, I would like to talk about technical debt as a meme. And what do I mean when I say meme? I don't mean like the familiar internet memes of funny things, more like the original idea, memetics, as it was originally conceived by Richard Dawkins in the Selfish Gene book. So the idea with memes is that, similar to genes, memes sort of compete for attention, and they reproduce. So memes, in this sense, is like a self-replicating unit of thought. So it's just like our DNA is sort of copied from person to person, memes are copied from brain to brain. Richard Brody called it a virus of the mind. Now that raises sort of an interesting question, I think, which is what makes a meme successful? And we can have different theories about that. Well, a sort of obvious thing when comparing to genes is sort of what does survival of the fittest means for memes. So is it the ideas that have the greatest explanation power? That's sort of one hypothesis. A very different take would be sort of the ideas that are most effective at reducing cognitive dissonance. So sort of the ideas that help us feel better, right? So you have sort of this tension between the best ideas and those that help us feel good. And with that sort of as a backdrop, what is technical debt? Well, we all know technical debt was is an idea that was conceived by Ward Cunningham. And Ward Cunningham said something like this, which is that shipping first-time code is like going into debt. So he's establishing this metaphor. A little debt speeds development so long as it's paid back promptly with a rewrite. So the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. So that's quite a rich metaphor. And we tend to sort of distill it down to this, basically two words, technical debt. And we don't sort of talk too much about interest on rates and debt load and standstill. Now, I'm talking about technical debt. What makes technical debt a good metaphor? As in a good idea. So it's very helpful for us because it gives us language to talk about something that is important about software development. It puts code quality or software quality on the agenda. Kind of one of the problems with code, obviously, is that it's not tangible. You can't show it to people. You can't say, you can just kind of like show it and say, look, this is a problem. So in some sense, it makes the invisible visible, which is very good, and we should thank Ward Cunningham for coming up with this metaphor so that we can talk. Let's see. Now, on the flip side, what are some problematic things about this metaphor? Well, monetary debt that we're sort of accustomed to is easily quantified. You know how much debt you have in the bank, right? Technical debt is much harder to measure. It's difficult to answer simple questions like, how much debt do we have? And important critical questions like, are we technically solvent? Is it possible to go technically bankrupt? So I think it warrants sort of digging a little bit deeper into what technical debt really is. And to try to figure out what it is, we should perhaps start by looking at what it looks like. Is it ugly code? A lot of time when people say we have technical debt, they mean that the code is, something's bad with the code. It's ugly, it's not the way it should be. And if technical debt is ugly code, it should be interesting to dig into what causes this technical debt. What makes the code ugly? Why is it ugly now? We'll sort of drop the base hypothesis that people wanted the code to be ugly. So let's presume that they wanted it to be good, but now it's bad, right? So is it lack of time? Is it because the project manager just doesn't understand me, the poor developer? Is it because the user experience people are unrealistic dreamers that have no concept of how terribly difficult it is to realize whatever concept they come up with? Is it because the previous developer was incompetent? Well, again, what does it look like? Well, from what I've seen as a developer, technical debt or ugly code that we tend to refer to as technical debt has lots of flags, Boolean flags, branches, and indirections. And whenever you sort of need to do something with that code, you just add another if branch, right? And sort of the task of your code now is to try to sort of manipulate these flags and levers or whatever so that you end up in the right place at the right time, right? And that you don't crash. More sort of abstractly, it's hard to determine where something starts and some other thing ends, right? It's difficult to isolate code that's related to one specific feature. And it's very hard to predict the effect of changes. So if I change something over here, what's going to happen? I don't know. Is it going to affect something over here? I don't know. And in general, it's very hard to reason about the code. Now, when we try to sort of compare these characteristics with the possible explanations we had earlier, or we could even invent other ones, like, does this imply that the product owner doesn't understand technology? Or that the previous developer used the wrong framework? Perhaps we should use microservices now, would that help? Or a NoSQL database, or we should go serverless, move to the cloud, move everything to Kubernetes, perhaps. So those are all like sort of like technical solutions to this problem with technical debt, right? But no, that's not going to help. And I hope that was obvious, right? But it's also obvious that something has gone fundamentally wrong. Because why are we in the place that we are, right? And there is something that has gone wrong in the process of capturing the business domain in software, because that's what we're trying to do, right? And when the code sort of fails to do that in a good way, something has failed. Something has gone wrong in understanding the business domain. Something has gone wrong trying to make and enforce decisions. And something has gone wrong in finding a suitable representation of the domain in software. And of course, we have a word for this process. It's not complicated, it's called modeling. Well, it is complicated, but the word itself is easy. So it's modeling that has failed. And we have more names that can help us. What is the name that we use to contain and conquer complexity? It's called abstraction. Now, unfortunately, abstraction is also the answer to this question. What is the name of the tool we use to create and compound complexity? That's abstraction too. So the process of modeling is applying abstraction to a problem domain. But it's also defining what that problem is, right? And I need to say this because every time you bring modeling up, someone's going to complain about big design up front, and we sort of agreed 20 years ago that that was a bad idea. But sort of trying to continuously work on your understanding and incorporating that into your software is not big design up front. Because it's not up front, it's continuous, right? And Ward Cunningham himself said as much. He said that you're wise to make the software reflect your understanding as best you can. So as you learn more about your domain, you bring that knowledge back into your software. Okay, given now that we have technical debt, how can we pay it off? We all know the answer to that question. How do we pay off technical debt? We do refactorings. But it gets complicated, because what kind of refactoring sort of untangles a mess of weak abstractions? And this is refactoring.com. This is sort of our toolkit. And it's hard to sort of, all of these are really sort of like miniature changes that you can do to your code that's supposed to be safe to do without changing the behavior of your application, right? So these by themselves are not going to help you much. You need to aggregate thousands of these to move in some direction that could hopefully help you improve your software. And Sarah May said this with a quote that I like, that a rewrite will end up with the same problems as the original unless you close the understanding gaps. You sort of need to move somewhere in your understanding of the problem if you're going to have any chance of cleaning up or paying down your technical debt. And it's sort of purposeless to try to embark on this refactoring journey if you don't also do remodeling. You don't sort of have, if you haven't moved anywhere in your understanding of the problem, then you don't have a direction for your refactoring efforts. Anything else is really just developers trying to play a hero, I suppose. So you have the software craftsman. And you have worked on your craft, right? You have done your katas, and you know all the practices. And the hope would be that you could alone, by means of your virtue, save the software, right? But unfortunately, the reality tends to be more like this. It looks good for a while, and then you sort of hit the wall. So-called best practices are not enough. I mean, they're good, right? In the same way that you want a surgeon to sort of clean their hands before doing a procedure, you do want to follow best practices when developing software, but you also need to operate on the patient, right? So clean code by itself cannot and will not save a rotten model. And trying to sort of save a rotten model by applying these principles will be a waste of effort. You need to fix a model, and then you can sort of start working on the code. Okay, well, are we done now? It's a short talk. How do we fix the model? What causes modeling debt? So if modeling debt causes technical debt, what causes modeling debt? And sort of, we haven't made much progress in some sense. Now, when talking about how modeling tends to sort of accumulate technical debt quickly, or that technical debt accumulates quickly if you don't do proper modeling, I have invented a short story. And the story is about a fictional software company called eQuest. And eQuest works with entities of this kind, which is, whoa, let's see what happened here. A horse. And eQuest is a big success. It is a software suite for everyone who sort of works with horses in some sense. Just breeding and feeding and everything you can do with a horse. I'm not a horse expert, but, well, you can do stuff like that. And in fact, the software works so well that your product owner says that we need to sort of expand. So we want to treat horse entities of this kind as well. So we have this new horse that we also need to sort of to work with. And it is an interesting horse in many ways. It's similar to your average horse, except that it's sort of shorter, stronger, and it tends to be seen as stubborn. It has a strong sense of self. But of course, mostly it's the same, so you should be able to reuse a lot of your software. And that sort of works nicely, but it causes some problems when you start to talk about horses now. Because when someone says horse, what does it mean? Is it this one? Or is it both of them? And for that reason, you start to invent sort of qualifiers when talking about the original horse. So it's the regular horse, perhaps, a typical horse, a true horse, old-fashioned horse, or my favorite, the horse. But that works well. You can work with that, and you sort of start to have things like this in your code. Like, so if the horse now is short and stubborn, you have your logic for the new horse, or else you can have the sort of typical horse code. And you go into production, and someone comes back and reports that there are bugs. Now, what would there be bugs? Well, it turns out that some horse owners, rather, have horses that they think are short, and they think they're quite stubborn as well. So when they sort of register them, it sort of triggers the wrong logic. It triggers the new horse logic and not the old horse logic. And so you're an experienced developer, so you know that these things happen, and you call meetings, and you realize that, well, there are other characteristics of this new horse that you can exploit as well. It makes a distinctive sound. It says, "ee-haw," whereas horses don't do that. They do something else, they neigh. So you have another thing. You invent this sound thing, which is good, and that fixes the bugs. Everyone's happy. In fact, everyone's so happy that you expand to this other kind of horse. And as a developer, you say, okay, what characterizes this horse? Well, it is the kind of horse that is the offspring of a regular horse, and a short and stubborn horse that says "ee-haw." So one of the parents is a real horse, or original horse, and the other one is a new horse. Now, this complicates the logic a bit. And even worse than that is that it's kind of hard to talk about this one in meetings, right? So perhaps you get creative and you say, can we talk about this and maybe say it's a half hee-haw or something like that when we meet specifically this one? But no one does that. But you can at least implement it in the code still, right? But there are bugs. Now, why would there be bugs? The logic looks good. Well, it turns out that it matters if it's the mother or well, there are not a lot of bugs. There are bugs in the reproduction unit, because it matters if it's the mother or the father that is the strong and stubborn horse. Because one of these can have offspring and the other cannot. And you're starting to get frustrated at this point, whereas the manager, of course, says, why is this taking so long? I mean, there should be plenty of applications for reuse. It's practically the same horses that we already have logic for. But you manage to work it out. And of course, it goes on and on, right? So we have yet another horse. You despair, and you wonder why this technical debt accumulated so quickly. I recommend reading a short paper by Stephen Gould. It's called What, If Anything, is a Zebra? It's a very interesting paper that sort of touches on some of these things. The premise of the question about the zebra is that there are actually 3 species of zebra. And the question that we sort of investigate is, do those three species of zebra form a single group, like descending genealogically, right? So, or are some of those zebras more closely related to real horses than to the other zebras? Because in some sense, if they're closer related to a horse than to the other zebras, then zebras don't really exist. And there's also sort of interesting history of the name of that article. It descends from another article called What If Anything is a Rabbit? And it's a reply to another interesting paper called Stripes Do Not a Zebra Make. But it's easy when we go through these stories to sort of be fooled and to think that the truth is out there to be discovered. We have this sort of ghost of Plato sort of teasing us and says, if you dig deep enough, you'll find the truth. Right? But there is no truth. It's just useful models or less useful models. And as we talked about, modeling is as much about defining the problem as it's sort of discovering something that's out there. And I have another story I want to tell you. This is the story of the place where I work. We don't do much with horses. We think a lot about TV shows. So what, if anything, is a TV show? Here's a TV show. This one's characterized by having sort of a narrative arc. It has episodes. So you start at the first one, and then you watch the second one, and then you watch the third one. And if you start watching the seventh one without watching all the other ones before, you don't sort of get the story much. But there are other kinds of TV shows. This is more like a brand of documentaries. This is the nightly news. This is a talk show. And all of these are sort of slightly different and quite similar, and they have different logic depending on sort of, if a user navigates to one of these shows, for the first one, you want to start at the first episode, but for this one, you definitely want tonight's show, not sort of like the first one we sent, which was in 1977. And then you have more interesting questions, perhaps like this, which is, in some sense, a TV show. It's, in fact, our most popular streaming TV show called Scum. But it's also more like an internet online thing where you sort of publish small snippets of video. There are Instagram accounts and stuff like that. So it's more like an environment, but it's also a TV show. So I sit down every day and think, how many kinds of TV shows are there? Well, there are things that aren't really TV shows either. There are sort of like sports events like this that all the Norwegians like to watch because we win. But it's interesting to sort of ponder these things and sort of work on what concepts we should use to sort of be able to talk precisely. And that depends on what we want to express. And, well, just sort of for fun, really. The horse example was very funny, right? So we have live events, and live events are like this. If you watch, or if you go to our website prior to the event, then it's sort of in a planned state. If you go during the event itself, it's actually live. And then afterwards, you can sort of watch it on demand, if you like. So that's sort of a simple notion of live. We also have live broadcasts, so you can go to our website and watch sort of the traditional linear programming, if you like. And you see this guy explain sort of the program for the evening on our main channel, NRK1. And some of these will be actually live, and some of them will really be on-demand stuff, but served live on the channel. This guy is definitely live. So to summarize, sort of the options we have is that you can watch live on demand. That would be watching the live event after it happened in replay. You can watch on demand live if you watch it through a channel. Or obviously you can watch live as well. And people actually say this at work. So language is quite terrible for these things, but it's the best tool we have. So we have to work with it, right? So it's inadequate, but it's our only hope. And modeling is quite hard. And modeling is hard for two reasons. One is the stuff that's being modeled, and the second one is those that do the modeling. That would be us. So the first one, why modeling is hard. In some sense, reality has no interest in being modeled. Reality is not tidy or organized. It's not even consistent. It's messy, and it evolves, and it sort of tries to escape your sometimes reality mocks you, right, when you try to do modeling. And we are trying to impose structure on something that's fundamentally unstructured. And it's not even bad, right? So if we want to innovate, we need to break existing models. That's sort of what it means to innovate, is to do something that no one has thought of before. So it's a good sense, sometimes. I recommend reading this book called Data and Reality. I think it's from late 70s or something like that. It talks a lot about databases, but mostly it talks about data and reality, which is obvious from the title. It discusses things like identity. What does it mean for something to be one thing? It discusses fundamental things like equality. When are two things equal? When are they the same thing? Is that the same thing? Being equal and the same thing? Is it equal or is it the same? Now, for us, these two things, are those the same thing or not? It depends on what context you're sort of investigating from. This is the Eurovision Song Contest. We have sort of a regular video of that, but we also have one that has sign interpretation, right? And in the playback context, that's definitely two things. It's two streams. But sort of from the perspective of the catalog, it's the same thing. So most of the metadata would be the same. Apart from details like this one could be longer or shorter than that one. So it's not clear-cut. And change is very interesting. When do two things become distinct? Something that was, you thought it was equal, but now it's changed slightly, and now they're not the same anymore. And what does it mean, or when has one thing become another thing? And categorization, which category does the thing belong to? Can a thing change category, and is it still the same thing if it does? Now, if you're into categorization, I recommend reading yet another book called Women, Fire, and Dangerous Things by George Lakoff. And what it discusses is how we categorize things. And the classical theory is based on properties, and software developers know this model very well, because we recognize it in programming languages like Simula and C#. I come from Norway, so I have to say Simula. Now, the idea with the classical theory is that necessary and sufficient properties determine if you're a member of a category or not, right? Now, to sort of illustrate issues with this way of thinking, think for a minute, what does a bird look like? Like, conjure up in your head an image of a bird. Did you think of something like this? Or something like this? Or this one, this is my favorite, this is the shoe bill. So, one critique of the classical model for categorization is that, in reality, some members of a category are more typical than others, and there are springs easier to mind, right? In some sense, a sparrow is more birdy than a penguin is. And a sparrow is more birdy than a shoe bill. And in fact, I think sparrow is probably the birdiest bird there is. Eagles are quite birdy as well, but I think like, for me at least, birds by themselves are quite small. So an eagle is too big to be properly birdy. So the idea is that the property-based classification is limited. And to sort of harken back to the paper that we talked about, stripes do not a zebra make, right? The property of having stripes does not necessarily mean that you're a zebra. And most of the stuff that I think George Lakoff bases his books on is, or that book at least, is Eleanor Roche's work on prototype theory. And the idea there is that some members of a category is sort of prototypicals, right? So the sparrow would be a prototypical bird. And then you sort of go further and further away from that until you start to say, oh, well, it's no longer a bird. So how untypical does it have to be because before it turns too untypical to be a member of that category? How unequal is it before it's too unequal? Or if you like, when does a donkey become a donkey? And the answer, it depends. It depends on who's asking, right? And who's answering. And those are the two participants in that discussion. The donkey itself doesn't care, it just is. Or to paraphrase Shakespeare, a donkey by any other name would smell the same. So what we do is we try to put things in categories to make sense of reality, right? And generalization is generally difficult because it's a hypothesis about the future, right? You say this generalization will always hold, this category will always hold, these properties will always be sufficient to determine what this category is. And for that reason, it's very dangerous to introduce sort of ad hoc artificial generalizations because they tend to be broken more often. And I just wanted to include that this is the last sentence in the article I mentioned by Gould. I do not believe that nature frustrates us by design, but I rejoice in her transigence nonetheless. Okay, that was sort of reality hitting us. Now, this will be us hitting ourselves. So those doing the modeling. A simple question, who makes software? Who owns technical debt? So we know that the technical debt exists in the software. Who makes it and who owns it? Now, in some sense, the rest of the organization would like it if it was so that technical debt was the problem of the IT department. And I think actually the IT department also likes that, because then they think they can fix it without anyone else sort of interfering. Right? So if it's a technical problem, we own it and we can fix it. If we were just sort of left alone for long enough and given enough money, we could fix it. This is a quote of a friend of mine, Roumeau. If you remake awful software from scratch without changing the culture that created it, you will remake awful software. And that speaks sort of ill of this idea that technical debt is something that the IT department can do. Because the IT department doesn't exist in isolation. It's part of a larger organization. And because this is a DDD conference, I have to make a reference to Mal Conway. I actually do recommend, if you haven't already, do actually read the paper. It's very readable. So don't just listen to sort of 40 years old something sort of misrepresenting what Mal Conway said on stage. It's much better to read it on your own. But of course, we have this thing, Conway's homomorphism, which says that an organization tends to produce self-portraits in the system it creates. And for that reason, people like to try this gymnastic feat, which is the inverse Conway maneuver. That I think it gives you a perfect 10 if you can pull it off, but you try to reorganize so that you can evolve your system in the direction that you would like. The problem, I think, is that existing system architecture tends to act sort of like organizational concrete. So if you reorganize and you hope that this will magically fix your system architecture, I think often you'll find that the system architecture will offer a lot of resistance and sort of create a shadow of organization, if you like, that supports the existing system. So that tends to be hard work. But nonetheless, I really like this quote by Matthias. If you design a system but you don't design the organization structure, you're not really the systems designer. Now, the divide, I think everyone talks about this. The divide between business and IT is problematic. And in some sense, the systems architecture and the enterprise architectures are sort of mutually dependent, right? It's hard to do good work in one area without considering the other. So, yeah. It seems we have come quite a long way from ugly code, which is where we started. And it makes you wonder why we're still talking about technical debt, if this sort of long journey that I followed makes any sense. Why do we still talk about technical debt? Well, one thing is that sort of the consequences of all these sort of human things and the problems of modeling and all that stuff are made very manifest and visible at the technical level. That's sort of where you see the effects, right? And then you have this thing that developers tend to look for sort of technical solutions to all kinds of problems, including the soft ones. And by soft ones, I mean those that involve people, right? You can't really... The sad thing is that those soft problems tend to be the hard ones. And technical tasks are very tempting. They tend to have a solution, right? And they tend to be possible to define quite well. Like, okay, we want to move this service to Azure, Kubernetes services, whatever. It might be hard to do, but you know when you've done it, right? And they fit our training and expertise. That's what we're good at. And this, I think, also is sort of quite important. It has a little psychology and politics involved, right? You just do it or you don't. They don't tend to lead to conflict of the sort of unpleasant kind that now these people hate me, right? And technical work is puzzle solving, whereas modeling work tends to sort of reveal tensions in your organization. So you sort of open a box and you really want to close it again because what you found was really unpleasant. But if you take this Conway's law seriously and the corollary to Conway's law that Matthias talked about seriously, you might actually need to do reorganization before you can do this, or to support this refactoring effort that you wanted to do. Now, with all of those things in mind, what is it that makes a meme successful? It's the question we started with. Is it that it has the greatest explanation power? Or is it that it's most effective at reducing cognitive dissonance? I'm going to claim, because well, you have to offer some opinions, right? Is that there are really no technical solutions to technical debt, and that the reason is that technical debt isn't technical at all. And that was the end of my talk. Thank you.
We have time for questions. So go ahead.
Any questions? Or you can catch me later, or hit me at Twitter.
One question there.
Hi. So if technical debt isn't technical, do you have a better name?
Now that's a good question. So the question, yeah, everyone heard it. Well, in some sense, I went by the way of modeling debt, or design debt. That's one thing. But that's probably not the whole story either, right? Because it involves all of these things that has to do with people. So probably I don't have a better name. That's not a very satisfactory answer, but at least it's honest.
We had a lightning talk yesterday, and the proposed name was domain debt, and I argue that the domain doesn't really have a debt to you. You have to model it properly, so you either build the modeling debt,
Yeah.
but it could be organizational debt.
Yeah, and probably the answer is both, right? Yeah. So it's not a single thing.
Yeah, most likely.
Yeah.
Any more questions?
More questions?
Okay.
There are a couple of questions, I think.
You catch it? Watch out.
Almost.
Just to comment, there's a really great agile coach. His name's Declan Whelan. And he's been exploring the idea of other metaphors, and the one that he's kind of landed on is technical health.
Okay.
So we're measuring kind of the health of the system and using doctors and things like that. So that is another
Interesting.
alternative.
Yeah, that would
Or
be interesting
yeah.
to see a reference for that. So I would definitely like to check it out. Thanks. There was another question, I think, back.
Oh, gosh. I'm going to need some help.
Oh,
Excellent.
that was great.
How am I going to top that? Thank you for a great talk. My question is, in your opinion, what is the right time or times in the process to tackle technical debt, right? Or modeling debt or design debt?
Yeah. Again, difficult question, good question. So the simple answer is continuously. I'm not sure if it offers much. I think, I want to avoid this idea that modeling is big design up front, but you need to do some work up front to sort of have some sort of ballpark direction for what you want to do. But apart from that, do more or less modeling work as you sort of encounter problems. So when your product owner comes with this new horse, that's probably a time for a modeling session, right? Spend some time on sort of digesting the changes. When someone introduces a new kind of TV show that we weren't prepared for at all, and a new sort of way of reaching our audience, we should probably allocate more resources to sort of exploring models than we normally do. So I think you need to sort of look at what's happening in your business to know when to do more or less modeling. Make sense?
I think lots of times what really helps is to actually force people that kind of come to you with that new horse issue, is that describe your problem instead of coming with a solution, because they often come and say, can you build a little change for a new horse?
Yeah.
And then you say, okay, I'll just add a couple of properties. So
yeah,
that requires a lot of training. Like, you need to force people because they have this mentality. Just add a field on the form, that's it.
Yeah.
How hard will it be?
Yeah, I think we should always be worried when someone has a solution
in their mind.
In their mind, that all you need to do is sort of follow this without reflecting over how is this going to impact, because that's sort of perhaps something we know sometimes better.
Yeah.
More questions?
All right. Oh, one more. We have plenty of time, and we have a break ahead, and we can use all that break time as well.
So, breaking a model, change a model means a lot of investment of people,
Yes.
on work behind, because, I don't know, even if we don't know, we use a lot of databases, okay? So if we want to break a model, sometimes that leads us to change also the data model, even if it's different, but that can lead us to this decision, and that takes a lot of time. So for that reason, we're going to build some kind of technical depth. I mean, we're going to change our model that represents our business, but we cannot change the model that represents our data. And this is a kind of technical depth, because we have to coexist with the past. Our history is important. So I don't know if you have some...
Mostly I just agree. I think it's a good comment. Just like when Ward Cunningham proposed the metaphor for technical debt, he meant that it's okay to incur some debt and then you sort of work at it. I think it's the same applies for modeling debt. And of course you need to, you're not going to be able to come up, I think, with a generalized answer to what you do in all of those circumstances, because every business is different, right? So it varies in how much that cost is going to be and stuff like that. So yeah, I think we're going to often incur modeling debt, and then we sort of need to work on what we think is the best strategy for handling that. Do we just accept it for a while? Do we start working on it? Well, that's the best I think we can do. I don't think we have sort of easier ways out than that.
I have a comment on this, if I may.
Yes, sure.
I experienced in a lot of cases that we, on that particular reason, like not touching the legacy data model, we kind of say, okay, it's easier to just adjust it, like adding more stuff in it. And then we get new horse. And if we continue doing this, we create hell of a mess. And then we say, we need to scrap this and rewrite it again. And no single full rewrite project ever worked. And that's proved. So I'd rather actually consider doing something with that. It might be a small step towards something else. Isolate this piece, put it aside, establish synchronization, and work in that bubble, what we call bubble context, right? But as far as you delay it further and further, it will be harder and harder until it gets impossible.
I think it's also important to do, whatever you do, sort of do it with open eyes and be honest with yourself and the stakeholders on what we're doing now and why. So we try to like be explicit about the impact of whatever decision you make, so that you don't sort of like just stack up those same kinds of decisions with the same rationale all the time, because then it accumulates until you can sort of no longer work meaningfully with it, right? So not at least accept that as sort of a generalized solution without exploring the downsides.
Absolutely.
Yeah, and trying to quantify it, which might be hard. But.
All right. I think we're done. Thank you.
Okay. Thank you very much.
Thank you very much.